Hi, this is Kevin. Today I'm going to talk about public key cryptography. Public key cryptography is a way for two people to securely send information to each other without worrying about someone in the middle being able to read that data. Let's check how it works.
Suppose you have a Pikachu and a sand Pokemon. The sand Pokemon wants to send a message to the Pikachu. However, there are hackers in the middle. The hackers are able to read any information that is sent. In order to secure the communications between the two Pokemon, they use public key cryptography. To do this, first, the Pikachu Pokemon creates two keys, a public key and a private key. The public key is available to everyone. Since the key is sent out publicly, the evil hackers would also have access to them. Now say that the sand Pokemon wants to send a message to Pikachu. The sand Pokemon creates a message and locks it with Pikachu's public key. Now the message can only be opened with the private key. The message is then sent over. Now the hackers can't open it since they do not have the private key. The Pikachu, however, has a private key and is able to unlock the message.
So that's the general idea behind public key cryptography. Now let's take a look at the details or the math behind it.
First, the Pikachu needs to create the private and public keys. The Pokemon first picks two prime numbers, P and Q. Let's say P is 7 and Q is 11. In real life, these numbers would be much larger, but for now, let's just stick with 7 and 11. The next step is to create a number, n, which is the product of P and Q. In this case, n is 77. Then generate the number z. That is the product of P minus 1 and Q minus 1. Here, z is 60. Next, the Pikachu chooses a number e. The number should have no common factors with z and should be smaller than z. Let's pick 17. There is no number you can multiply with 17 to get to 60, so we're good. Next, we choose a number d. We need to pick d such that e times d minus 1 is divisible by 60. Let's pick the number 53. Because 53 times 17 is 901, minus 1 is 900, and 900 divided by 60 is 15. So we know that d is good. Now that we have all of that, our public key would be a combination of n and e, which is 77 and 17. The private key is n and d, or 77 and 53. Now suppose the sand Pokemon on the right wants to send a message in the form of a number to Pikachu. The secret number that the Pokemon wants to send has to be smaller than n. Let's suppose he picks 12, because he's a Seahawks fan. In this case, the value of the message to send, or m, is 12. The Pokemon uses an encryption function to encrypt the message using the public key. Using the encryption function and the values of the public key, n and e, the encrypted value, 45, is generated. That number is sent to Pikachu. Note that since the hackers do not have the private key, they will be unable to decrypt the message. The Pikachu takes the encrypted message, 45, and then, using a decryption function and the private key, is able to decrypt the message. The Pokemon gets back 12. So they both know the message is 12. This might all sound trivial, because the numbers we're using are small. But imagine if n, e, and d were super large numbers. How are we going to guess that?
The encryption method I just explained is called RSA, named after the three people who invented the algorithm. Now, public key cryptography is used every day. One of the more common uses is HTTPS.
HTTPS is a way for you to access a website's information securely. It allows you to view sensitive information, like bank information, without fear that someone will be able to intercept and see the data. Nowadays, almost all websites are on HTTPS. When you try to access a website using HTTPS, a certificate on the server tells you, or your browser, that the server is legitimate and can transmit secure information. The certificate in this case contains the public key, as well as a few other things. When you access the website and get the information, you are using the contents of the certificate as a public key to encrypt the data. And that is how the data is transmitted securely. You can see all of this if you go to a website that has HTTPS, like Google. The padlock next to the URL means that the site uses HTTPS. All of the content between your browser and Google is encrypted. If you click on the padlock button, you can see that the browser says that the certificate is valid. You can see more certificate information if you click on it further. For example, this certificate is valid for the entire google.com site. It's issued by a Root Certificate Authority, GTS. It's valid from October 3, 2021 to December 26, 2021. On the right, you can see additional information about the certificate. Here's the public key that I was talking about, which is used to encrypt the site. This public key has 256 bits. That's equivalent to a 78-digit number. That's a hard number to guess.
Public key cryptography is a vital technology that is used in everyday life. Well, that's all I have about that topic. Please don't forget to like and subscribe my channel. I hope you all had a good day, and I'll see you in a future video.